Hello, and thank you for joining my presentation. My name is Denise Evans, and I am going to show you what I've learned about earthquakes and tsunamis. First, I thought it might be helpful to explain to you exactly how the Earth's structure is. Of course, there is the solid core at the bottom, very, very hot. It's about 760 miles, so that's pretty low there. The fluid core is the next up, and the fluid layer about 1,400 miles thick, and it's mostly composed of iron and nickel. Now the lower mantle, that is the entire mantle that is 1,800 miles thick, which certainly means that the lower mantle makes up the bulk of this part of the earth. It gets hotter, is certainly at greater depths. And the upper mantle, as you can see in the diagram, is just beneath the crust, and it ends, of course, at the lower mantle. The thickness of the upper mantle is between 200 and 250 miles. And of course, the top one is what we call the atmosphere. Now, this is a layer of gases, commonly known as what we know air. That is exactly what surrounds the planet Earth, and it's returned by the Earth's gravity. In this slide, we're talking about oceanic versus continental crust, plate boundaries, and volcanoes. There's two types of crust. Of course, there is oceanic and continental. Oceanic crust is generally found under the oceans, and the continental under land. Although plates are usually a combination of oceanic and continental crust, there are some key differences between the two types of crust. The oceanic crust is 3 miles to 6 miles thick, and it's composed primarily of the basalt, diabase, and gabbro. The age of the oldest oceanic crust today is only about 200 million years. Now, the continental crust is typically from 20 to 30 miles thick, and is mostly composed of slightly less dense rocks than those of the oceanic crust. The present average age of the Earth's continental crust has been established to be about 2 billion years old. Now, the plate boundary location is where two lithospheric plates meet. Plate boundaries are associated with geological events such as earthquakes and the creation of a topographic feature such as mountains, volcanoes, mid-ocean ridges, the oceanic trenches. The majority of the world's active volcanoes occur along plate boundaries, with the specific plate's ring of fire being the most active and widely known. A little bit off of the earthquake thing, but it was important in here. Then we need to think about the seismic waves. An earthquake is a sudden release of energy along a fault. Now, the rocks along the faults tend to move in all directions, and it's constantly moving. And at some point, intense pressure builds up, and the rock layers give up because the pressure is so great. A fault is a sharp break in the crystal rock layer. Now, all natural earthquakes happen in the lithosphere, which that depth is 200 kilometers below the Earth's surface. Once these rock layers give way, then come the shock waves. Scientists can measure the shock waves, seismic waves, using a seismograph, but still no concrete way to predict the earth, when the earthquake is going to happen. That's an unfortunate part about that. On this slide, it is actually defining for you all of the fault line locations. Now, there's a lot. There are a lot of them. In North America, we're only seeing that on the California coast side, and that is actually quite a long fault along there. But all of the rest of the red marks here are showing us exactly where there are faults, and certainly we can see that there are quite a few faults here in the eastern world, part of that. I wanted to explain a little bit about the three different types of faults. You've got your normal fault, or they call it the thrust fault, and that is a thrust fault is where it dips and the upper block above the fault plane moves up and over the lower block. That happens a lot more than the other two. The reverse fault is forms when the hanging wall moves up. The forces creating the reverse faults are compressional, pushing the sides together. And the strike slip fault is moving in a horizontal way, certainly not vertical. This movement is lateral between the two plates. So those are the three basic faults, and the earthquake and tsunami that I picked actually is the stripe slip fault. Okay, predicting earthquakes. Not really possible. What scientists do know is that there are some regions around the world that are more likely to have earthquakes. It is not possible to accurately predict exactly where or when earthquakes will happen. After the earthquake does happen, scientists can measure the seismic waves and know exactly where the earthquake started and how powerful it is. Now, the tsunami, we can tell, scientists can tell if it's out far enough that a tsunami is coming. But tsunami is a series of waves that were created by that undersea earthquake. Or certainly volcanic eruptions. When a tsunami begins out in the ocean, the waves are not very high. Now, as the depth of the ocean decreases, the waves build higher and higher. When the enormous waves hit the shore, everything is destroyed in its path. It's very sad. The earthquake and tsunami that I chose to talk about was a 7.5 magnitude earthquake, and it triggered a tsunami. Now, this was in Indonesia. It is the central Sulawesi province. It happened on Friday, September 28th, 2018. Now, this tsunami created the landslides, which makes it all that much worse. They had widespread destruction. They are sure that there is loss of at least 2,000 lives, and 4,400 of those of other people were seriously injured. Now, 68,000 homes damaged or destroyed by the tsunami and the landslides. Total affected people they're approximating is 1.5 million people. Now, on the map, you can see that the epicenter is right in the middle of that red, and then the tsunami is like this way. It can go in all directions, but it did hit Indonesia. In this slide, I'm showing you just a couple of the sad photographs that were taken after the devastation of the tsunami and the landslides. And scientists, I mean, they're saying this earthquake was a fast slipping strike slip at the Palu Coral Fault. And I have added an extra map that shows you that exact fault. Now, this fault can produce up to 40 millimeters of a left lateral motion every year. So it is moving, as we talked about earlier. They're constantly moving. 40 millimeters of left lateral motion every year. That could add up to a lot. The strain takes hold for many decades or centuries, and then suddenly the strain is released. That's the earthquake. This is what happened at this Palu Coral Fault. Now, due to the depth of the earthquake at 10 kilometers and 80 kilometers north of Palu, the tsunami was triggered and waves reported at 20 feet high. The above is a small fraction of the devastation in Indonesia suffered from this tsunami when it hit their land. Thank you for taking the time to watch my presentation on earthquakes and certainly the tsunamis that can come from the earthquakes. I have listed my reference page for your convenience, and certainly I listed where I got pictures from and information from, and certainly our class textbook as well. Again, thank you for taking the time to watch my presentation. Have a great day.